Good morning, learners. How are you doing? I trust that you are doing well. Welcome to today's class. Today we're getting to learn on a gradient, that is under the topic equation of straight line. We're getting to know how you can be able to find gradient of a line when you're given points, any two different points. Yeah. So welcome so much. I trust that you can hear me from your hand. Kindly confirm. So in case you have a question, you can feel free to text. You can feel free to text or raise up your hand, and then I will open up your mic so that you can ask. So on our introduction bit, we'll be getting to define what is a gradient. What is a gradient? What is a gradient? What is a gradient? So we are saying that we find gradient by getting to have the x coordinates and the y coordinates. When we have the y coordinates in what we are calling the vertical distance, for example, as you can see from my diagram here, this is a vertical, if you can see my cursor here, this is a vertical distance. That is the difference in between the y2 here and the y1 here. So that is what I'm calling the vertical distance. Then the horizontal distance is the change in the x coordinates. The change in the x coordinates, that is from this point here, x2 here and x1 here. So for you to find a gradient, for you to find gradient, you will have change in y over change in x, change in y over change in x. That is to mean you'll be having a y2 here, you'll be having y2 here, y2 minus y1 over x2 minus x1. We are saying that for you to find gradient is equals to change in y over change in x, change in y over change in x, change in y over change in x. So change in y, we are saying it is the vertical distance, that is the change in y, while the change in x is the horizontal distance. So this is a formula for finding gradient. This is a formula for finding gradient. This is a formula for finding gradient. Yeah. So let's get to look at some examples here. Let's get to look at an example. Let's get to look at an example. Okay. So we are told that we try on this. We have in these points 1 0 and 4 9, 1 0 and 4 9. So we are getting to say that the 1 0 here we having the 1 as a x and 0 as a y. Then in the other point that you're given, that is a 4 9, that is a 4 for the x coordinate and a 9 for the y. So we are saying that for you to find gradient is equals to change in y over change in x. So in this case it will be, in this case, let me write, in this case it will be 9. So it will be 9 minus 0, 9 minus 0 divide by 4 minus 0, 4 minus 1, divide by 4 minus 1, divide by 4 minus 1. Of which you will get 9 minus 0 is 9. Will be 9 divided by 4 minus 1 is 3. So your answer will be 3. That will be your gradient. So to the next one here, we are given we are given the points, the coordinates, that is 1, 2, and 7, 8. So we are getting to say it's changing y over changing x. That is 8 minus 2. That is 8 minus 2 is 6. So it's 6 divided by 7 minus 1 is 6. So in this case, our gradient will be 1. Our gradient will be 1. You can try see. The coordinates are reading 2, 2. The point is 2, 2 and 5, 8. 2, 2 and 5, 8. 2, 2 and 5, 8. I want to see your answers. Try this. Just want to see your answers. Just want to see your answers. Okay, thank you. So in this case, the answer will be 8 minus 2, that is 6, divided by 5 minus 2, that is 3. So 6 divided by 3 is giving us 2. So to the next one, D, another example. We'll be having the points are 2, 3, and 3, 6. As you can see on the screen, 2, 3, and 3, 6. 2, 3, and 3, 6. Change in y, that is 6 minus 3. 6 minus 3 is 3. Divided by 3 minus 2, which is 1. So it's 3 divided by 1. You end up getting 3. The next one, another example. We are given the points 1, 3, and 3, 7. 1, 3, and 3, 7. So we'll be having 7 minus 3. That is change in y. That is 7 minus 3, which is 7 minus 3, which is, thank you. 7 minus 3, which is 4. Divided by 3 minus 1, which is 2. So we'll be getting our gradient here is 2. Be getting our gradient as 2. Be getting our gradient as 2. We'll be getting our gradient as 2. Now you can have a question in form of a word problem. For example, this one is the one showing on your screen. Calculate the gradient of the line which passes through point C, that is -1 and 5, and point D, which is 3, 7. So for you to be able to work out this one, you still need to use the same formula. You have x1, which is a -1. You have y1, which is 5. You have x2, which is 3. You have y2, which is 7. So we are saying change in y over change in x. That is y2 minus y1 over x2 minus x1. So in this case, y2 is 7. So it will be 7 minus 5, which is 2. 7 minus 5, which is 2. And then 3 minus 1, which is 4. 3 minus 1, which is 4. So 7 minus 5, that is 2. 2 divided by 4. 2 divided by 4, you'll be getting to have an half or 0.5. So here is some practice questions for you. It reads, find the gradient of a straight line. Calculate the gradient of the line from point A, that is 3, 4, to B, 9, 1, using the gradient formula. Another question, calculate the gradient of the line which passes through E, that is 2, 4, and F, that is 4, 2. Determine the gradient of a straight line exercise. Calculate the gradient of the line AB. So I'll be getting to show you the line AB from the diagrams below. So what is the gradient of the line which passes through the points C, that is a -6, -2, and D, that is 1, 3. So you'll get to do that to mark your attendance. Getting to do that. Any question so far? Any question? Any area you have not understood? Any? So it's clear. Nice one, nice one. Nice one, nice one. So this brings us to the end of this class. Thank you so much for being part and parcel of this lesson. I urge you to keep on practicing and keep on working it out. Say practice makes perfect, but I believe that perfect practice makes perfect. So keep working it out, keep practicing, keep doing the best, and keep loving mathematics. Say mathematics is life, it nurtures. Goodbye. Enjoy the rest of your day.